Hello everyone, welcome back to our math class. Today in this video, we are going to talk about a new type of logarithm, which is called natural logarithm. And this one, we will use this one to compare the common log we mentioned before. To start the lesson, we're going to do a quick review. So let's check these two logarithms. As we mentioned before, logarithm is actually looking for the exponents. The way we set up is always log, follow up this base, and then we just need to figure out 3 to what power is 1 over 27, which they know the answer, which is, you are correct, which is -3. And as you can see, this number is always the answer, so this one is asking us 3 to what power, so that's why we mentioned log is looking for exponent. Same thing here. And another one we call common log, because when we see no base here, that doesn't mean it's no base. It means the base is 10. We just do not write 10 over there. So it's same as log 10, right? And this question is asking 10 to what power is 1 over 1,000. So we know that it's going to be -3. Same thing here. So very similar to the natural common log. Natural logarithm is actually talking about another type of logarithm, and they also have a very special number as a base. And to introduce a natural logarithm, we are going to introduce a new type of number, which is called number e. It's not type of number, it's a very special number. The reason we mentioned that this number is very special because, first of all, just like if you do remember in the past, when we start introducing the number system, we know there's a very famous number pi, which is a ratio between the circumference and radius. So the pi is irrational number, because that means this decimal will continue forever but will never repeat. So that's a very special feature for that. Another number e is also another very famous irrational number. And the pi is related to the ratio between circumference and ratio. E actually related to the exponential growth or decay model. So we actually, in real life situation, we use E a lot in modeling all kind of exponential growth or decay. And a lot of actually E, the discovery of E and the definition of E can go very extended lesson here. So it's definitely beyond the concept wise in this situation. But right now you can keep that in mind. E is irrational number, and the approximate value is 2.72. So this number is, again, this is actually forever. It will go forever number here. And also, if you want to look for this number on the calculator, you can look for this little e here. If you see the key under the log, which is ln, and if you just click second to this one, you will see the e. And for example, I just do e to the first power, and you will see the value. So this is basically this, again, decimal will go forever, and approximate value we can just see is 2.72 here. And also the reason we call E, because this one is discovered by the mathematician Euler. So the more information you want to find about this number, you can definitely search by yourself, but we are not going to go to more details here. Okay, so the natural logarithm, the reason we call this natural logarithm, because we are going to use this number E as a base. So if you check the key here, you see the ln, right? And if you see the graphing calculator here, this key here, you see the ln. Then what is ln? Ln is actually same as log e. So when we use e as a base, instead of using writing as log e, we actually write as log. For example, log e to the third. So that we can rewrite it as log 3. Or we can say log e to the 7th power. Again, you can just change this whole part as log e to the 7th. So from now on, if you see the calculator ln, that means this is log e. Just like when you see the log here, meaning log 10. So we use e as a base, and this logarithm we call natural logarithm. So to have better understanding that, we are going to do several practice regarding that. Again, it's just a new type of thing, you see that, but the idea for the log is actually carry over everything we learned in the past. Law of logarithm, the definition for the log, looking for the exponent, everything here stay the same. So let's check the first one. As you see, when you say ln, meaning log e, so the base is actually e, just like when you say log, the base is 10. We do not write 10, but the base is still there. So this one is actually same as this one. This one asking us e to what power is e? Of course, this is going to be 1, because any number to the first power is itself. Okay, next one, if you see this one, again, whenever you see the line, meaning log e. So this one is asking us log e to 1. So that means e, let's use a different color, e to what power is 1? As we mentioned before, any non-zero number to the 0 power is 1. So the answer is 0. So as you can see, everything carries over. It just, we are talking about the base e here. So this one, again, when you say line, meaning log e. So this one is asking us log e to the e to the fifth. So this one is asking us e to what power is e to the fifth? So of course, as you can see, e to what power is e to the fifth? Is 5. Very straightforward, right? And this one, last one, is asking us, again, even you see line, meaning log e. So this one is asking us log e to the 8, meaning e to what power is 8. Of course, you know, there are certain cases we cannot use mental math to figure out. So this one, we use calculator. So since this is the line 8, we just click line, and then put 8, close parenthesis, enter. Let's say I'm going to round this to the nearest 10th. So this one can be 2.1. If I round it to the nearest hundredths, then they can be 2.08. See, this is how we understand the natural logarithm. And the natural logarithm, again, the base is very special irrational number e. Okay, so that's all I want to share with you for the natural logarithm. Of course, this topic can be very extended lesson, but based on the concept wise here, that's all we are going to discuss here. Thank you so much for watching this video and study this topic with me. Thank you for watching and take care, everyone. See you soon.